In this lesson, we're going to talk about 2D adaptive clearing for pockets. 2D adaptive toolpaths are often used for clearing out pocket areas. Because of the way adaptive clearing calculates toolpaths, it's very efficient for odd-shaped pockets with sharp corners. 2D adaptive clearing is the right toolpath to use for removing large amounts of material quickly. It can rough the outside to leave a boss standing, or rough the inside of closed or open pocket boundaries. On this part, we have both open and closed pockets. One of the great things about Fusion is that we will be able to machine both with the same operation. Select 2D Adaptive from the 2D Toolpath group. On the Tool tab, the first thing you'll notice is that it has the same tool we used in the last operation. But we actually want a smaller tool to rough out the pockets. Press Select to pick our cutting tool. If you click on the document heading Intro to 2D Machining, the middle section will show only the tools for this project. Pick tool number 5, the 3/8 inch diameter flat end mill from the list, and press Select. We will leave the default speeds and feeds for this tool. Let's go to the Geometry tab. This time, we want to cut the open pockets and the closed pockets. Let's look at the tooltip for pocket selection. This tells us that we can select faces, edges, or sketch geometry to define our cutting boundary. Selecting a face may give you a different result than picking an edge, but both of these are preferable to picking a sketch. The face and edge are directly associated to the model, so if the model changes, the related toolpath will update. Associative toolpaths are always better than being attached to a set of static sketch geometry. Here's a general rule that I use for selecting the area to machine. If the face has holes in it, you might want to pick the edge. No holes? Pick the face. Let me show you why. Pick the face at the bottom of the closed pocket and press OK. If we rotate and zoom in, you'll see the toolpath rapids down and then starts its side cutting on the pocket. That face we selected has a hole in it, so Fusion assumes that we can plunge into that hole. But we know there is material in that pocket. Right-click on the toolpath in the browser and select Edit. Go to the Geometry tab and press the X next to your pocket selection chain to delete it. This time, let's select the edge of the pocket and press OK. You may have to right-click on the toolpath and select Generate to update it. This time, you'll see a red helix cutting its way down the final depth. A face sees the hole, an edge sees the boundary. Right-click on the toolpath again and select Edit. Go to the Geometry tab and press the X next to your pocket selection chain to delete it. This time, let's select the edge of the open pocket. See how the blue cutting area extends out to the tangency of the radius? Delete the selection again, and this time pick the face. You can see now it is only evaluating the boundary of the face. So it can make a difference in your results depending on how you pick the cutting area of your pocket. Pick the face on the opposite side, and then pick the edge of each of the closed pockets. Let's go to the Heights tab. We can see that our bottom height is set in reference to the selected contour. Even though the two pocket types are at different heights, Fusion will cut them to the correct depth because the depth is associated to the selected contour. This also means that if someone changes the depth of any of these pockets on the model, the toolpath will update without us having to change any parameters. There's nothing for us to change here. Let's go to the Passes tab. Our optimal load is showing 0.075, which is 20% of the 3/8 tool diameter. That tells us our formula is working. Stock to leave should be checked. Set the radial stock to leave at 20 thousandths and set the axial stock to leave at 0. This will leave stock on the walls, but not on the floor. Check the box to enable the smoothing option. Let's go to the Linking tab. Down in the Ramp section of the dialog, you'll see the ramp type is set to Helix. This is how it will enter into the solid area of the closed pocket. There are a number of ramp types. You can view them in the tooltip. We will leave the ramp type set to Helix. Down below that, you'll see a helical ramp diameter and a minimum ramp diameter. If you right-click on either of these parameters, you will see that these values are based on a formula. The ramp diameter is 80% of the tool diameter, and the minimum ramp diameter is 25% of the ramp diameter. Again, there's nothing for us to change here, so we will press OK. And there is our toolpath, roughing the excess material from the open and closed pockets. In this lesson, we learned about the 2D adaptive clearing strategy for open and closed pockets, selecting a new tool, selecting a face versus selecting an edge for the cutting boundary, and some of the helix ramping parameters for entering into a solid area of the stock. Press Ctrl+S to save the part, Command-S on the Mac.